So these are just more examples of absolute value inequalities. That's the backside of the notes page that is in the previous video. So in order to start the process, remember we have to isolate the absolute value. This is the problem where we don't have the absolute value isolated already because it's currently being divided by 4. So we need just the absolute value by itself. So before we can do anything, we have to isolate it. So let's isolate it by multiplying by 4 on both sides. And when we do that, we get the absolute value of q minus 1 is greater than or equal to 8. Now we can begin the process of writing our two individual equations based off of this inequality. So remember, we take the positive value just as it is. So q minus 1 is greater than or equal to 8. And then on the negative value, we have q minus 1 is less than or equal to negative 8. And when we solve those two, we're just going to add 1 to both sides. So we have q is greater than or equal to 9. And over here we'll add 1, and we'll have q is less than or equal to negative 7. So now when we graph those, we have a closed circle at negative 7, and q is less than that, so it's going to go to the left. And we have q is greater than 9, which is over here, and it's going to face to the right. Our interval notation, this is an OR, so it's going to have two pieces. We have negative infinity, comma, negative 7, and it's got a square bracket because it's equal to, union, square bracket, positive 9, comma, positive infinity. So that's that particular problem. So the remainder of these problems on this side of the page, I'm not going to walk through the whole process, but I'll solve them and pause the video so that you can pause the video and do the work yourself and then check your answer. Okay, here's problem 6. You try it and then check your answer. Here's the solution to the problem. Note that we had to first isolate by subtracting the 3 from both sides, and then we're able to create the two separate case equations with the situation where we have the absolute value isolated. So we have the positive value here with the less than, because it's less than in the inequality, and then we have the negative value, and we reverse the inequality. All right, so I'll graph it, and then you can check your work. Okay, so we have the lowest value, negative 4, and the highest value, 1.5. Of course, it's parentheses because neither one of them are equal to. Here's problem 7. Go ahead and work it and then check your answer. Here's the work for both cases. So remember, we isolated the inequality first by, the absolute value, first by dividing by negative 10. And notice that when we divided by negative 10, we had to reverse the inequality sign. It's at that point that you can then split the inequality into two separate equations so that you can solve for both your positive value and your negative value. I'll graph it and then you can check it. So here's the graph and the interval notation, and notice that I changed the mixed number into, the improper fraction into a mixed number. Just makes it a little bit easier to graph 3 1/2, rather than 7 halves. Same with over here, negative 5 halves, I changed it to negative 2 1/2. Okay, here's problem 8, so go ahead and solve it and then check back. And here's the solutions. Again, remember, make sure that you completely isolate the absolute value. So we first had to add 5 to both sides, then we had to divide by -9, because we really need that absolute value to be all by itself before we can start creating our other two equations. Graph it and check back. And here's the graph. And notice again that, remember we said that greater, so the greater than sign, because the absolute value is the distance away from 0, it's getting greater and greater and greater. So it's getting beyond 8, so it's going further and further and further towards infinity, and that's exactly what we have here. So we have an or situation. So whenever we have a greater than sign, we always get an or situation, because the distance away from that center point is going to be increasing according to the greater than sign. Okay. Here's number 9. Go ahead and finish it and then check back. Okay, there's the solution. Graph it now. And there's the graph and the interval notation. Here's problem 10. You need to solve it and then check back. And there's your answers. Again, we had to isolate first, doing all this work over here to finally get to the absolute value by itself. And then we separated them into the two different equations and solved. Graph it and check back. And there's the graph. And remember that we had a greater than when we started, so whenever we have a greater than, we're going to end up with an or situation. Here's 11. Go ahead and work it. And there's your answers. So go ahead and graph it and check back. And there's the graph. Here's our final problem. Go ahead and solve it and then check back with the video to see if you did it right. And here's the solution to this last problem. Again, notice that we isolated by doing a bunch of work, first adding by 9, then dividing by 4 to get the absolute value by itself. And then we set up this equation here and this equation down here. So the positive number kept the inequality sign the same. The negative number caused a reversal of the inequality symbol. So graph it and check your answers. Alright, so there's the answers to that one. If you recall, we said that when we have a less than, we will end up having an and type of a graph. So here's the graph and the interval notation.